the effects of bending and warping of space-time is, but we don't know why it happens.
You don't know the effects of bending and warping of space-time. When
we
you
do.
looked out at the distant galaxies, you went, what the heck is going on here? There must be missing matter. So we don't know the effects unless we want to imply a mathematical placeholder.
No, if I have a satellite...
Zanick, hold on. Zanick, is the Earth in an inertial state or not?
Is the Earth in an inertial state?
Yeah, I heard you earlier with Jeremy. Is the Earth inertial or not?
Is it? You said is it in an inertial state? In what respect? Because it has multiple aspects of the Earth that you could be talking about.
Well, this is the problem. This is the problem with your model.
Well, no.
Like you claim the Earth is on a geodesic around the sun, correct?
That it rotates around the sun.
Okay, you don't even know, dude. Go look it up, dude.
No, it's not. No, it's not. It's not in a. Sorry, I had to think about it a second. No, it's not in a geodesic around the sun. Absolutely not.
Yes, it is. Yes, it is.
No, it's not.
Yes, it is.
No, it's not. Free falling is not a geodesic.
It's free falling around the sun. It's free falling around the sun. That means it's geodesic, dude.
No, it doesn't. So, it means
just like satellites. Just like satellites free fall around the Earth.
They're not geodesics either. That's a Whitsidism. No, that's wrong.
Geostationary satellites are not.
No, they are not following a geodesic. No.
Okay, dude. Go. I suggest you go look this up and come back before you sound stupid.
I don't have to look it up. I already know that I have knowledge. The reason that something orbits the Earth is because the centrifugal force is matched by the centrifugal force. The centripetal matches the centrifugal. The geodesic is straight down to the center of the Earth. That's the geodesic. That is, by definition, the geodesic. The reason that it floats and free falls is because it's falling around. Now, if I drop something straight down, it is following a geodesic. It is in free fall. You know the difference. People
I'm not, dude. I'm not. I can't continue the conversation if we can't even agree on that. So yeah, I can't.
Well, no, do you not agree? Okay, so what is following the geodesic? If I drop something, is it following a geodesic?
A geodesic is a circular path around the Earth, but it's a straight line.
No, that's not.
It's actually space.
That's not the
definition. Yeah, dude. It's actually space-time bending around, right? Mm-hmm. Causing things to look like they're curving, but really they're traveling in a straight path, bro.
You're talking about two different things right there. Geodesics are forces of equal potential. Those are geodesics. So if I had a line of geodesics, like we talk about the geoid and look at the shape of the Earth, the supposed round Earth with all these weird bumps on it. That's the geodesics. Those are the geodesics. That's Jurassic. The geodesic is straight down. If something's in free fall, dropping is different than something free falling around the Earth. They're not the same thing. They're not the same. They can't be. You can't have a geodesic that's straight down and also a geodesic that's around the Earth. The reason that things circulate the Earth is because they are actually matched. The centrifugal force is matched by the centripetal force, which makes it go in a circular path. Even though it's in a free fall, it's not following a geodesic.
Well, it's perpendicular. It's perpendicular to the geodesic.
Exactly.
Omnivore would disagree with you because I was talking to Omnivore.
He's wrong. About this. He's wrong. I heard him say that too.
Well, I don't know. You guys got to figure it out. But anyway, so free falling. You're free falling on the Earth, terminal velocity, right?
No.
And then your
terminal velocity is not free falling.
Hold on. When y'all Zanick, you're wrong. I just looked it up, and it says yes.
If I'm wrong, I want to be corrected.
Read it off. I can't. I'm driving. I can't.
I know. No. Hey, I got your back.
Can you read that?
I'm not gonna pigeonhole you if you can't see something on the because you're driving. So yeah, if I'm wrong, I want to know for sure. Please.
Yeah. So geodesic is in geometrically of cubes. No, not of cubes, of balls. How do you call it? What was the damn name of this?
Slopes. Does someone have something to add? Are you going to tell me why I'm wrong, please?
Yeah. So a geodesic is basically a great circle. That's the word for a great circle in what is it? Global geometry? No, what's the business term or the
geoid or the ellipsoid versus the geoid? The geodesic.
Spherical geometry is the name you're looking for. The name you're looking for is spherical geometry.
Can you just repeat?
Spherical geometry.
Yeah. So, and there a geodesic is the term for a great circle, which is
Right, we're not
basically
talking
the
about that in that
representation of
context.
a
We're talking
straight
about the
line
force
on a
line.
ball.
We're talking about force lines.
Yeah,
we're not talking about geometry.
Leon was referring to this circular path.
We're talking about geodesics in the terms of like geodetic. The term geodetic. We have a force line, the direction of forces. That's how you surveyors would actually survey your land if you want to see if it's going to flood based on not the ellipsoid but the geoid. The geodesics. A geodetic surveyor is looking at force lines, not geometries.
Yeah, and I think there was the misunderstanding. So what Leon meant is a geodesic, which is that great circle line.
Yes.
Hold on. Let Elbow. Elbow's been trying to get in. Elbow, go ahead.
It says, yes, according to general relativity, the Earth is considered to be going around a circle, around a path around the Earth, so it is considered to be geodesic. So I'm just reading it off and kind of.
Yeah, that's its path.
He's disagreeing with that though.
No,
can you pull up another source that at least disagrees with that?
Yes, it's following a geodesic path geometrically. You're right. What I'm talking about is.
Thank you. So you concede to that, right? The Earth's on a geodesic around the sun, right? I'm not talking about geodetic surveying, dude. Even though it's related, we're not talking about surveying. We're talking about relativity.
You said there's no forces acting on it, and it is following a geodesics. I'm talking about geodesic term, like geodetics.
Yeah, I'm not talking about surveying, dude. Stop trying to deflect.
I'm not deflecting.
The Earth
is following a circular path. It doesn't mean, and it's in free fall, but it's not following the geodetics. Sorry, geodetics.
Actually, the Earth is following a ellipsoid path around the sun because it has not equidistance all the time.
Yeah, but that's not based on.
That's not. Hold on. Dude, I'll get there. I'm trying. Just one step at a time, dude.
Hold on,
dude. Wait. Just wait a second, bro. We gotta do one step. I'm gonna get there with the ellipses, dude, the elliptical orbit. I'm gonna get there, but first we had to establish a foundation so we can move on. And that's all I'm trying to do. Is the Earth on a geodesic path around the sun or not? And our satellites on a geodesic path around the Earth or not? Can we establish that first?
Yes. Sorry.
Okay, can you just say
I mixed the geodetics and the geodesics mixed up. Yes. I was using the wrong word. Sorry.
No, that's fine, bro. So, okay. So what does that mean though? Right? When an object is on a geodetic path, what does that actually mean?
Geodetic path.
These are fancy words.
It means
it's circular. It's circular. Right? It's circular, right?
Geodesics is a circular geometric term, yes.
Right? It's circular. While simultaneously, catch this, guys, catch this. It's a circular path, right? Due to space-time curving, but it's also a straight line. It's not actually going in a circle at all. It just looks like it's going in a circle because of the reference. And that's why you don't feel a centrifugal force that's actually translated that you can pick up with an accelerometer, because the Earth is on a geodesic path around the sun. It's not curving at all. It's actually going in a straight line. But to complicate things even more, it's not actually going in a circular path. It's going on an elliptical path. So how do you make sense of that in your model?
Well, because you have a balance of forces. The geodesic, that curved path is the shortest path, as you said. And so it's kind of complicated to try to explain. There's a difference between the geodesics. So what happens when you drop a ball? So look at something being dropped to the ground or something orbiting the Earth. You think they're the same? Are they both geodesics?
That's a good question. I mean, in your model, either way, it's space-time bending.
But if I stop going around the sun, like I slowed the Earth down, or satellite, whatever's going around the sun, where would it go? Would it go right into the sun, right? So I've only slowed it down. I haven't done anything else but just changes velocity, and then suddenly it's going straight down. So the geodesic also is straight to the sun.
But you got to understand that even though the Earth is curving around the sun, it's actually following a straight path, and it's following the curvature of space. That's your model, dude.
No, it's not following the curvature of space time. That's not true.
Hold on, bro. Wait a second. Both the Earth and the satellites that are moving around the Earth are both following the curvature of space-time. And even though they look like they're going around in circles, they're actually going in a straight path.
That's not true, and that's why I'm trying to So I love this conversation. By the way, this is one of the areas I'm probably least equipped to explain. I know intuitively what's going on, so I like talking about it. So if I make mistakes, I apologize. But I was kind of on that track too, thinking that like you're in orbit, you're inertial. But then I was corrected by someone, a physicist that was talking to me about it, and it was a while ago. And then he gave me the analogy of dropping something down that follows the geodesic straight to the center of the Earth. Something in orbit has to be traveling at a velocity around the Earth. Otherwise, it won't be in orbit. It won't be weight. It cannot be weightless unless those forces, which are actually perpendicular to each other, are matched. So when centripetal force, which is that force of pulling inward, is matched by the centrifugal force, which is the force pulling outward based on this change of direction. When they're matched, you are weightless. Now, the question is, and I don't know the answer right off the top of my head, are you truly inertial at that point? I don't think you are.
Exactly. And I was going to get there, bro. That's my next. So this is why it gets very confusing, because it seems like dialetheism. That's what SE calls it, dialetheism. I learned that word from him. That's why I give him credit constantly for that.
You say that,
so you have like the contradicting things that occur in your model all the time, bro. So that in order to be truly on a geodesic path where you're following the curvature of space-time, you have to be in an inertial state in your model, according to relativity.
Yes.
An inertial state means that you are at rest. So even though the satellites are moving at incredible speeds, 17,000 miles per hour, they're supposed to be at rest. And what that means that they're in an inertial state means that there's no forces. There are no forces acting upon it. And hold on, at least no real forces.
No,
so when it comes to hold on, I'm almost done. When it comes to the Earth, the satellites are just a micro of what the Earth is, right? The satellites are a microcosm of what the Earth is around the sun. The Earth acts as a satellite around the sun. The Earth is also traveling on a geodesic, and it's following the curvature of space-time. And gravity is not a real force. And centrifugal forces are actually not real forces. They're fictitious. They're pseudo forces, right? And they can't be picked up with accelerometers. That's why they're considered pseudo forces. Hold on. So how can you be in a geodesic path following the curvature of space-time in an inertial state, yet also have the rotational energy, right? The Earth is spinning, right? That energy that it is, you can pick up theoretically with an accelerometer, and it is considered a real force. It's considered a proper acceleration versus the centrifugal forces that you would theoretically pick up, or if it was possible. I mean, it's actually impossible. It's allegedly a pseudo. Centrifugal pseudo. Did I make any sense there?
Remember, pseudo force only means a force without origin, and it's reference frame dependent. It just explains how there is a balance of force between the pseudo force, and that's what's so funny about this question. And you're actually going about it in the absolute proper way. By the way, I have to give you that. Think about it. If gravity, which is the bending and warping of space-time, is causing this attraction, it is considered a pseudo force. But we talk about it as in terms of a real force because you have weight and things, and we can measure that. And then you have centrifugal force, which is also, so you have two pseudo forces. You have a pseudo force of centrifugal force, which is the outward, and the inward force is also a pseudo force, which is gravity. So it's really kind of a paradoxical, argument and exercise in contradictions, I guess, like as Essie would say.
Exactly. And that's my whole point. That you have to gravity and centrifugal forces that have to be pseudo and fictitious.
They're both pseudo, though.
I know that.
They're both pseudo.
Yeah, I mentioned gravity and centrifugal.
Centrifugal force is actually the only one true force. That's actually the fundamental force above all.
Centrifugal force is definitely pseudo force.
I know you just want to shout through me. Don't make me mute you, Zanick. You hear me?
I said talking. One thing. I said it's actually a pseudo force.
Okay, I don't need your lecture, bro. All right, you're confused, and you're going to spread that onto me, and I don't accept that. So anyway, yeah, magnetism.
Centrifugal force is pseudo.
All right, bro. I'm done, dude. You have fun.
No, hold on, dude.
Don't go. No, I'm sorry.
We're having fun, Zanick. It's okay. Just let him get his word out. He hasn't even talked at all.
I'm good, bro. Yeah, I'm good. I'll just
I want to
hear
what you have to say.
Zanick, everybody. Yeah.
Go ahead, Die Slow. Centrifugal force is
no, he's breaking up anyways. You're breaking up, Die Slow.
I mean to chase him away.
All right.
Dialethalism is paradoxical. That's what Lion said from the very beginning of this whole thing, and now Zanick has agreed to it. So it sounds like we do agree that it's not like an official great model or anything. It's got paradoxes built into it. It's not good.
Well, think about, even if these forces are reference frame dependent, which they are, and we have bending warping of space-time causing a deflection, and you can follow a geodesic, which is a straight line, even though it looks like it's curving from another reference frame. We know that if I'm traveling in space, inertial, so truly inertial, no force is acting on me anywhere, and I start
built this on like 3 false premises. You just built this whole thing on 3 false premises.
No, we're just trying to say I have an object that has. Okay, then I'm dropping an object. I'm just dropping an object, and it's hitting the ground. How is there no forces acting on it yet we see it's accelerating to the ground? That's a whole nother discussion. But if you shoot it off into the distance at 22,000 miles an hour and keep it going 22,000 miles an hour, you will be weightless in it. It will be weightless.
How do you know that?
No forces acting on it. But
you have no idea if that's the case.
We do. We measure those forces all the time.
So real quick. So the Earth is supposed to be weightless, free falling, experiencing weightless. And gravity is not a force, and centrifugal is not a force. That's why it's considered to be in an initial state, at rest, while simultaneously still experiencing a change in velocity. Even though it's minute, you have to include the change in velocity because of the analemma. You have to include that, and that is something that is in your model. And not only that, you also have the spinning, the rotational force to contend with. So even though it's supposed to be in an inertial state, you still have the rotational force that in your model is considered a proper acceleration. How do you make sense of that?
It's not, though. I'm just trying to explain that when you're in orbit, you're actually matching the centrifugal with the centripetal forces. They're matched. We know those forces are there because we can actually test for that. You stop making that change, and some of the other force that's present will dominate and pull you down. So you're not following a true geodesic. You're not following a true. I guess geodesic is not going to be the right word now. Geodetic
no, you're
path.
Right. You're right. You're absolutely right. And the thing, that's what I'm trying to tell you. You can't have a change of velocity and be in an inertial state. Yeah, that's exactly what you have in your model, dude. I promise you.
Right, but we know that the balance, when those forces are balanced, we have a balance of forces, which means there's no net force. That's okay. Like if I push against the wall and it's not moving, and I'm pushing and I'm sweating, the wall's not moving, I'm sweating, no work's being done, no net force is being applied, yet I am pushing on the wall and the wall's pushing back. There's no net force. Doesn't mean there's no force.
There is work being done.
No work being done. And metabolically there is. Metabolically in your body, we're not talking about that. We're talking about the net force between your hands pushing against the wall, which is going to take, or you know what? Forget about the body. 2 things leaning against each other. You have 2 2x4s making an A-frame. There are forces at the apex that are acting on each other. There's no net force. It's not moving, yet there are forces. I can have a spring between them that is compressed. We know the forces compress the spring. No work is being done. The forces are there. Just like orbiting around the Earth. 2 forces exist. There's no net force. It's not inertial. I got to find something that actually can...
it's inertial, dude. The Earth
no, it's not truly inertial.
I know that, but they say that it isn't. Go ahead.
If you're pushing up against the wall, how is the wall acting on you?
Because it has to. All forces have to be balanced.
I see.
Equal and opposite.
I see the confusion now. Good.
Another thing that I want. Somebody brought up the 3-body problem. This is only going to get worse for your model. I'm just want you get ready. Are you sitting down? I want to make sure you're sitting down so you don't collapse. So the 3-body problem is something that just complicates things even worse when you can consider relativity. Because what we have, when you look up the Milankovitch cycles, right, and all the wobbles and the elliptical orbits, and then you start using Kepler's laws to justify all of that. So Kepler came up with this shit to try to justify the Earth revolving around the sun. He had to make the orbits work. So when you start looking into Kepler's 3 laws of motion, planetary motion, bro, you have not only do you have an elliptical orbit, you have the focal point, which is the sun, is off centered. It's off centered, so it's not normally like if you're spinning something, right? You're going to be the focal point. The focal point's at the middle, right? A way to understand it is it's like having a bungee cord, right? And you're spinning let's use Newton's bucket. You have a bungee cord tied to Newton's bucket, and you're spinning that bucket in a circle. Where would you expect the focal point to be on Earth? In the middle, right? Right?
What do you mean
the focal point.
You're spinning a bucket. What happens?
The focal point, the foci. Where do you expect the focal point to be if you're spinning Newton's bucket in a circle with a bungee?
Well, you have a force. You could have it totally straight out, and your water will still be at a 45-degree angle in the bucket.
Right now, if you had Newton's bucket filled with water and you had it tied to a bungee and you spun it around, the focal point would be in the middle, right? And with Kepler's laws, the only way that he could make the planetary motions work with 3 bodies, and this is still a problem today, bro, is if you include an off-centered foci, so it's an asymmetrical orbit, and it's elliptical, and it changes in velocity, and yet you still have it's still inertial. Yet none of that can be replicated on Earth. It's all theoretical. You can't. This can't be done on Earth. It's impossible. The 3-body problem can't be replicated on Earth.
Because it's all mathematical abstractions. Learn what that is already, please.
It's the same reason why you can be. It's kind of like the bungee cord and the bucket of water, and if it had some elasticity in there, it could still be orbiting. It'd still be, well, let's go back to what you really talked about, the satellite orbiting and having an elliptical orbit. How's that possible? Because when it's closer, it has to be going faster to count, and the centrifugal force has to be faster, or centripetal force has to be is greater, so the centrifugal force has to be greater to match it. And when it goes farther away, it would slow down because the centrifugal force would need to be less because the centripetal force is less. So it makes sense that elliptical order would have a balance of forces all the way around. Even though it's elliptical, the speed changes, which is a force. This rate of just change of speed is exactly matching the gravitational strength, which is what we would expect. So that the 3-body diagram is easily modeled for that reason.
Right. So hold on. Let me just make sure for the audience that they're understanding what I'm saying. So, when you have a race car, a NASCAR, when it's going around the bend, the greater the bend, or a Formula One racing, the greater the bend, right, the more G forces are acting upon the object, right, or the vehicle.
Yeah, my race car going
that
around
translates, right?
My race car at turn 1 going 155 miles an hour around turn 1, entering it and exiting it. Yeah, at the apex, I'm just freaking getting pressed into my seat because it's banked too. By the way, it makes it more of a complicated problem. But the suspension's loading, it's getting squished to the ground, and I'm like, oh, my jaw's getting heavy because I got like almost a G of.
Yes, that's centrifugal force. Right now, you guys act like that's a pseudo-fictitious force. That's fine. I get it. But the Earth it's spinning around the sun, right? And it's not even though a geodesic path is supposed to be a perfectly circular path, right? No deviation. Yet
no.
there is deviation. Hold on. There's a 3 million mile deviation from the epihelion to the perihelion.
It's a straight
Every 6 months,
line.
There's a 3 million mile difference, dude.
Yes,
right.
It's a
from
straight
how
line,
close
though.
we are to the sun, dude.
You've basically created a balance. You've balanced the equipotentials are balanced the entire way around, which means it's a straight line as far as the object's concerned. It's going a straight line. It's like you said, it's got a net zero force on it the entire time because when it's going closer to the sun, it'll have a faster rate of change of direction because its the centripetal force is higher, and when it goes farther out, it has a slower rate of change of velocity because it is turning at a slower rate, which means the force is less, but it's farther away, and there's less gravitational strength. centripetal force pulling it in. So the balance of force, that's what defines the elliptical orbit. That balance, that geodesic is the straight line path that it's taking. You're right. And I was wrong to argue with that in the very beginning. Had the wrong term in my mind, talking about the balance of forces.
Yeah, I'm just trying to get you to concede that even though you have this crazy elliptical orbit with its asymmetrical focal point, it has obliquity, you have all these things to contend with, while simultaneously it's not actually doing any of that. It's going in a straight path because of the curvature of space-time, and it's in an inertial state. So even though you have elliptical orbits with change of velocity, none of that matters because it's following the curvature of space-time. It's actually going in a straight line.
Let's just get textbook definitions back into the viewer so we can also debunk this one. A geodesic is not a real force or entity, but a mathematical convenience derived from the framework of general relativity. The assumption of space-time curvature is necessary for geodesics to be meaningful, but space-time itself has never been detected as a physical medium. Geodesics do not describe physical causes, only mathematical correlations within an assumed model, meaning it's an mathematical abstraction. Any observed motion can be described without geodesics, meaning they are not necessary to explain real-world physics. Thus, to summarize, the concept of geodesics is not a fundamental truth of nature, but rather an interpretative tool used within an artificial framework. It can't get more logical than that. Call that my word salad left lane, then good luck.
You know, it's an interesting discussion, and it's one I have always been. It's always challenged me because you think about this for a second. So I think we all, with the help of Torah, we've all now become very familiar with this term geodesic, which is we all kind of knew it before, but I think we now know it even better now. It's just, and we all knew it was a straight line path. I was thinking it was more like the lines of force that are going to the center of the Earth, but it's actually considered to be this. You're following geodesic going around the sun as well, because that line of those forces are balanced, and it becomes a straight line path for that object. But here's the rub. So what happens if an object? Hold on.
Real quick.
If it's truly a geodesic, I mean, there's no forces acting on it, and it's a circular path around the Earth, for example, then what would happen to like a rocket that's pointed to the Earth and you're going just a little bit to the right of it as you approach the Earth? Would the rocket get captured by the gravitational pull and then start going around it like a merry-go-round where the chairs are always facing down, or would it follow it like it's following a straight path, like the rocket would turn around, the nose of the rocket would actually turn and turn all the way around? Like, I'm thinking it doesn't do that, but I could be wrong. I'm wondering what you think on that. Would it turn?
The question is, sorry, Lion. Yeah.
No, you can go. You can go, bro. Go ahead.
If I'm in a car floating in space, going to the Earth, I'm hitting it, I'm going at 17,000 miles an hour, I'm traveling, and it starts to grab me. I'm pointing, let's say at this one moment in time, I'm pointing toward the sun too. So I'm got the Earth and I got the sun behind it, and I'm pointing to the sun. Do I continue to point to the sun even though I start going in orbit and the car acts like a merry-go-round chair? Or does it follow? If it's really truly following a geodesic, why wouldn't the nose just follow? Like, it doesn't know, shouldn't have any kind of changing in rotation at all. It should just follow the straight line path around the Earth. What do you think it does?
So just to get
by the way
around here,
it's let him get in, and it's line, by the way.
I mean line rather. Sorry,
it's all good.
Let's get you guys confused. The little icon.
A lot of people do. It's weird, but it's all good. Zanick, you're gonna go? I mean, not Zanick. Siak.
So, you gotta have common ground first. Do you concede or agree that first and foremost that the geodesics are not physical paths but mathematical constructions?
That's for you.
Was that a yes, Zanick?
It's a mathematical construction, not a construction, a description.
Well, sure, that's just being semantic, but
not really. As you're saying, we're like constructing it to create it. construction is creation.
It is.
We're seeing
it's a calculated trajectory and not a real force or guiding mechanism.
No, it is a force, a real guiding mechanism, and we're describing it with mathematics.
No. It's a mathematical construction and a calculated trajectory and not a real force or guiding mechanism. This is textbook definition. It depends on a metric tensor that is arbitrarily assigned based on general relativity's assumptions. And so since space-time is not an entity, but a conceptual framework, since it has never been proven to be actual or real, any curvature assigned to it is a product of mathematical convenience and not physical reality. That's ABC logic for you. You get the ABC logics of space-time not actually being physical reality, not actual, not real.
The evidence points to this physical reality that space-time is warping, therefore objects and light and things will bend in the presence of large bodies of mass.
Yes, but you see, you're conflating a lot of artistic renditions within a desire to imagine it working in a certain way with the actual real world and reality, in which you have no evidence of this space-time at all. You see, it's a mathematical construction, and just because you've built years and years and years, or not you, but the body of science has built years upon years of using a tool to get self-evident points to it supposedly being real, doesn't make it any more actual when it doesn't have any actual physical proof of its existence.
It does. It
you
has
see
evidence.
Your own material falling on itself now.
No, then why when you're flying, why does an object become lighter going eastward than going westward? Why does the object become lighter? Why does the object lighter at the equator than at the North Pole? What causes that?
That's a good question, but forcing upon it this idea of a mathematical concept doesn't answer the question. It's the same as saying that let's say you disprove of technology, and then I start to attack you for talking with me on the phone. It doesn't hold together. A geodesic is still not a physical path, but a mathematical construction, because it is a calculated trajectory and not a real force or guiding mechanism. And as I said, it depends on a metric tensor that is arbitrarily assigned based on general relativity's assumptions. Note you that they are assumptions and not actualities, not physical reality.
They're not assumptions, though, because we have evidence to support them. If they're assumptions, then we can make assumptions in our theories, and they could be disproven or not disproven, but it can be disproven, or you could be replaced by something that has stronger evidence for it, but is not an assumption.
But what is an evidence? Did you forget what evidence is?
I know what evidence is. I see light behind the sun that I normally wouldn't be able to see if the sun wasn't there. Angularly, that it changes. Its rate of change is greater as it approaches the sun. So how do we see something that should be behind the sun that we see alongside the sun where it should be behind the sun? What would cause that? Our reasoning is that the bending orbiting space-time says the gravity of the sun will actually bend light. The space-time is warping and bending so much that the light is bending around the sun.
Another good question. But you see, geodesics is still a mathematical construction. You can attempt to use it.
It's a mathematical representation of that idea that if space-time bends, then geodesics are straight line paths, but they are bending, and they would allow us to see things like refraction allows us to see things that are lower than they are behind obstructions.
Correct. Exactly what you said there is correct.
But we don't have any atmosphere for this light to be bending around. It's not following Snell's law. No.
Correct. It's based upon an idea. And then the idea is not the actual real thing. It's what's imagined to be working in a certain way, right?
All right, hold on. So
he's figuring it out.
Well, yeah. Well, he already. I mean, it is a mathematical concept. I think, or he said, "What did you say? Construction? What did you call it, Zanick?"
Zanick, I called it mathematical construction.
Explanation.
No, but what did he say? What'd you say, Zanick? It's a what?
He said it was a construction. I said it was an
and
explanation.
You said it's an explanation. Either way, I mean.
He used 3 or 4 different words for it.
All right, fine.
Construction.
But the whole this all started with inertial and non-inertial reference.
Right.
That's how this all started. So is the Earth inertial or not?
It's very important to know that the geodesic motion has to assume space-time as a physical medium, yet at the same time the paradox is that it has never been able to prove space-time as a physical medium, which is what Lion has been attempting to hint at here consecutively. Another point is that the geodesic principles conflicts with the concept of force, so we got a great paradox there. And then the very notion of straightest path in curved space is in itself arbitrary.
But real quick,
not true.
All right, go ahead. All right, go ahead.
On Earth, actually.
I'm just trying.
Guys, don't interrupt Siak. I'm trying to doze off for a nap here. Go ahead, Siak, please.
Yeah, it's good that you. Yeah, no problem, Jeremy. It's a good moderation if you want to sleep.
I'm just saying, don't interrupt, please. Let's let Siak finish.
Wrap it up, Siak. It's all good.
Take your
time.
Say
you gotta say.
Take your time, Siak.
Yeah, okay, thank you. How many minutes do you want me to use?
Just be concise, but
I mean, I can open my textbook behind me here, and I can read for you some pages of what.
Dude, just hurry up, man. People are waiting to talk, dude. People are waiting to talk. Finish your thing, please.
I am not the one holding this room. It's Lion and Zanick talking about ideas that they can't ground in reality, or at least they try to.
So you're done. Are you done or not done?
I'm helping you being finished with this topic. Do you not realize
All right,
that?
I'm gonna just make a judgment call. Go ahead, Lion.
Yeah, I appreciate it. So this all goes back to Jeremy's question, actually. Is the Earth in an inertial state or not? See, Zanick. And I think you agreed that in your model, even though your model says it's supposed to be an inertial state, it's not in an inertial state, correct?
Well, if these geodesics are these lines of force or the straightest paths around, like the sun, for example, then why would those paths be such different shapes for different for light versus mass? Like all mass will follow those geodesics, right? It's all velocity. It's all a velocity based model. But light, when I shine light 1 million miles, 10 million miles away from the sun, the light doesn't go into orbit. So how could it follow the geodesic if that's the shortest path? It's only the shortest path because the object has mass, and the mass is attracted to the center of the Earth, not the sun. But light is also affected, but to a lesser degree. I mean, that doesn't make any sense.
It's not a gotcha, dude. I'm not trying to pin you in a corner or nothing like that, dude. I'm just wondering, what you think. You don't always have to follow your model, bro. So I'm saying you don't have to follow.
I'm definitely not following my model. If I had a PhD physicist in here, or even a physics person that was experienced in this particular area of GR and SR, I think they'd be lambasting us for not understanding this. But I think I've actually asked this question before, and they didn't want to even address it very well. We talked about tensors, we talked about other things, but the general questions are like, if truly following a geodesic, to your question, are we really truly inertial? If that means there's no forces acting on us, then what would happen if we're following the geodesic? What would happen if something entering the gravitational pull of the Earth, if it was an object, would it continue facing the direction it was traveling, or would it follow the geodesic like a racetrack? That's a question I've always had.
You have to put the satellites into a geodesic. They don't just automatically go into a geodesic because, like you said, you have to balance out the forces to the point where they're free falling around the Earth consistent. Yeah, right? They're not falling towards the Earth. They're not moving. They're not, falling away from the Earth. They're falling around the Earth.
Right.
And then they got boosters. And I brought this up to Omnivore because I was like curious myself. I'm like, Omnivore, where how can a satellite be in an inertial state following the curvature of space-time, yet you need boosters to kind of keep it in track? As soon as you start applying boosters, bro, like that's a force.
Yes.
That's coordinate acceleration. But yet you're still in an inertial state. Like how? Like make it make sense.
Well, that's like well, you're right in the fact that it's inertial, but it's not truly inertial because it's still hitting stuff. It's in space and things are still slowing it down. It never speeds up. It always slows down a little bit, so they got to kick it up a little bit to get it back into proper velocity, in proper orbit.
Yeah, I haven't even brought up drag yet, dude. If you include a little bit of a drag,
that's why they're hitting particles. Even though it's not that many, over a period of a year, period of months, there becomes enough drag on the spaceship impacts that slow it down. Because it's not a perfect vacuum. That's why.
Dude, space-time just has tons of problems, bro. I'm trying to make them glaringly, they're so obvious, bro. I don't know. Just to us that aren't, we're not like committed to that model. We can see it, see the problems. And it's just as problematic as the flat earth model. If you think the flat earth is problematic, bro, you should probably look at your model, intellectually honest. You would see that problems, bro.
If it's truly a geodesic, I would think that an object that is falling to the earth and doesn't fall and crash into the earth or get deflected and bounce off in a different direction, if it actually got captured and went into orbit, like do we have anything in orbit? Do we have any natural objects that are orbiting the earth, like any meteors or anything that's actually orbiting? I don't think we do we? Must be kind of
I don't know.
Must be a very low percentage.
There's this little thing called the moon.
I was going to say the moon, but I think it's whatever. Okay.
They have the moon orbiting and it's falling.
Yeah, but I'm talking about something that actually
fall, except the only problem is it's falling up.
Right.
Right.
Falling up.
Falling up, Zanick.
How's it falling up?
It's falling. That's what an orbit is, something in constant state of falling. And the moon is getting 4 centimeters farther away from Earth the surface of Earth. So if you move away from the surface of Earth, that's called up.
Yes. Okay, I see what you're saying. So the orbit is getting larger and larger every year. But my point was an object. If it was an object to be captured by the Earth and didn't crash into it and it didn't get deflected, it got into orbit like we insert our alleged spacecrafts around the moon, or we put satellites in orbit. That speed it travels, or the orientation that it has when it got captured by the Earth's gravitational pull, does it rotate like a Ferris wheel chair, or does the nose of this object always follow the direction path it's taking? So it's going straight, it sees the Earth, it gets captured, and now it's constantly turning around the Earth without any kind of adjustments or thrusters or anything. That's a challenging question.
The moon's another example of the microcosm of what the Earth is doing around the sun, right? Because the moon also has its own elliptical orbit. It's called the pedigree and apogee, right? And it's somehow on a geodesic path, following the curvature of space-time.
Not pedigree, perigee.
Yeah, there you go.
I guess what I'm saying is, do things naturally become tidally locked as they enter orbit because they're following the geodesic?
So the moon also doesn't have a perfectly circular path. It's elliptical, and it's also following a straight line path. Because you gotta understand, it's space-time bending around the moon, dude, and around the Earth.
Are you saying that it's pear-shaped, not circular?
It's elliptical. The orbit. Pear-shaped is the shape of the Earth.
An elliptic is the shape of a pear. It's the same as the shape of an egg. It's an ovoid.
No, it's pear shapes talks about something.
Keep on with something you know about, Zanick. Clearly, you don't know about shapes.
No, it's not pear shape. It's.
Then what shape would you call a pear?
A pear shape. It has a very
I would definitely call it a pear shape, but here's the real question:
Well, you might want to Google it, Mr.
I call it voluptuous.
Hello.
Mm-hmm. I call elliptical is elliptical. We all know what that means.
Like why? I know you guys can hear me.
It's not pear shaped.
The thing is, I hate you, Zanick.
I know you do.
The thing is, you can prove a shape. You know what I'm saying? Like shapes are provable. So when these guys talking about you can't prove things in science, say okay, and then in the next breath they're gonna say something like, "Oh, we're gonna do science. And the result is gonna be the shape of Earth." Just know they're talking out both sides of their mouth.
Yeah, I know, dude.
But if you want to call a pear an egg, that's fine. I mean, it's generally
your number one science communicator talked about the Earth being pear shaped.
Yes, that's true.
That's hilarious.
You live on a pear. It's fine.
It doesn't look like an egg. It looks like a
pineapple
pear.
under the sea and a pear. You know, maybe the whole universe is on the inside of a giant coconut. Like, who knows? You guys are living
model may not be perfect,
some
but
kind
at
of
least
weird
they have a model.
fantasies.
It may not be perfect, but at least they have a model.
You guys are living out some kind of weird fruit fantasy. One more time. You guys are living out some kind of weird fruit fantasy.
Like I said, it may not be perfect, but at least there's a model, right? At least there's a map. At least simple things like one-to-one between what's happening in the ground and in the sky is maps. These are simple concepts that FE has yet to hurdle over.
All right, great, dude. You're gonna come in here every day and tell us. You come in every day and tell us we don't have a map. We don't have a model.
Every day.
Dude.
I know.
You just do it day after day after day. It's like, we heard you. We got you.
That argument though is like, yo, that pig has lipstick on it and a hole, so therefore it's a woman, bro. Like, you could do it still. You're allowed to do it, man.
Let's see if I can get this out without being interrupted. Are you people, seriously, you globe-shaped people, still stuck on the fact that 200 years ago an observation was made down in Antarctica, and you guys have been arguing the fact ever since? Nothing has changed.
Which Antarctica are we talking
because
about?
you can draw something for it to make sense, you have to be in that frame of reference for it to make sense. So when have you ever been away from the fucking solar system to observe it?
What are you talking about?
That's the point. I think you just proved your point, Josh. Yeah. It's like the Schrodinger's cat, also called thinking outside the box, and not when you're trying to think about something, you just don't still use your old ideas to attempt solve the problem, because then you're not really thinking. You're just trying to match your old ideas. And usually they're not your ideas, they're just adopted ideas. You're trying to match that with new things. It's like creating a painting. And then your father tells you that he doesn't want the color red in this painting because you are creating a painting for him. And then you keep using the red paint still. It's like, he asked you not to use red. Why did you keep using red?
He asked you to stop painting the pig's lipstick. Stop putting lipstick on the pig. Oh, dude.
Did the globe die?
You know, I heard that some people are so obsessed with something that they can get a turd to a very high sheen polish. Still doesn't mean that they have anything special. It's just a piece of poop.
So to get it out of the way then, to finish this talk about satellites free falling without geodesics, and now invoking Newtonian mechanics, gravity, inertia, and inertial frames or non-inertial frames.
All of these concepts are still concepts. All their claimed realities of being real, fundamental, and privileged reference frames are still actual the status of descriptive correlation, postulated assumptions, and conceptual constructs.
Oh, I got some news. This had just come across like early last night. Trump is cutting a large portion of NASA's budget. Yes, it's happening.
All those fancy words, no one gave a fuck because it didn't really mean shit. What would you say about NASA's budget?
Oh, Trump's cutting the budget of NASA.
Biden's going to give it to Elon.
That's dope.
Joshua, let me just repeat it because it was so bad what I said. The entire paradigm of gravity, inertia, collapse as a system of conceptual convenience rather than actual real forces or phenomena. Badumts.
No one cared the second time.
That's unfortunate that no one cares about the reality that we live in, but we still have a server here called Earth's Awakening. I mean, okay.
I'll buy that.
Nobody cares.